In the last video, we discussed different types of particular integrals, correct? Like you had 1 by a square plus x square, 1 by root of a square plus x square, 1 by x square minus a square. Like this, we had different types of integrals, right? Now, in this video, we'll solve few problems. Okay, very few will solve just to show you or just to introduce you to those type of problems. That's all. All right. So look at the first one. You have dx divided by this, correct? Now, whenever you have a quadratic polynomial like this, you need to split it. Split in the sense not splitting the middle term. Of course, that works very well, but most of the times you will have equations where you won't be able to split it. That means in these type of problems, you have to do the whole square form and then you have to get it. All right. Now, look at the first one. We have integral of dx over x square minus 6x plus 13. Now, if you look into this one, you won't be able to split it, right? So, what we do, look at the denominator. Denominator, you have to write in terms of the whole square. That means here, let's do the math what we are supposed to do. X square minus 6x plus 13. We'll try to get it in a whole square form. Now, here also a particular part is, see there is a minus sign. If there is a minus sign, it will become a minus b whole square. If that was a plus, then a plus b whole square. Alright. So, first thing what we do now is we'll try to convert this into a minus b whole square. Let's by comparing the terms. In the sense, here x square in C, we'll compare it with a square minus 2ab plus b square. Okay. Now, what is there in place of a? Like if you compare, a value is nothing but x value, correct? A is x. Now, minus 2ab is equal to minus 6, correct? So, minus minus cancels to 3 times. But what is a? A value is nothing but x. So, look at the LHS. You have x into b is equal to 3, isn't it? Or if you look at this one, you can call this as 6x. Okay, because minus 6x is this one. So 3x is this, b value becomes 3. So b is 3. We got a, we got b. So we have the last term to be b square. Correct? That means 9 should have been there. But we don't have a 9. So what do? You add and subtract. Or in some of the cases, you can just see 13 can be split as 9 and 4. That is also correct. But I would always suggest you do add and subtract b square, because in certain cases you might have fractions. So when you have fractions, it might be a little hard for you to understand. That's why. So what we are doing is that if you look at the denominator part, see you have x square minus 6x plus 13, correct? So we'll write this as x whole square, like a square minus 2 into x into 3, 2ab. See, 2 into x into 3 is 6x. But we need to have a 9. So what you do, you add 9. You can't just add 9 directly. Subtract 9. Okay, add 9, subtract 9. Next is plus 13. So the extra thing what we are doing is this. Now you might be thinking, when you add 9, subtract 9, it's the same. Why are we doing these things? Here comes the grouping part. Okay, so first thing what we do, you group all these things, only these many terms. So when you group them, see this is of the form x minus 3 whole square, correct? Next minus 9 plus 13, that's 13 minus 9. 13 minus 9 is what? 4 plus 4. So x minus 3 whole square plus 4. Now this is one method of completing this square. There is one more method. That is, you take it as a by 2b and you're going to do it. That is one more method. That also we'll see later on in the later on problems. All right. So this method is what we call as comparing the coefficients method and then solving. All right. Anyway, now here the denominator, the question changes to I is equal to integral dx by x minus 3 whole square plus 2 square. 4 is 2 square, correct? Now see to this one. This is of the form 1 by x square plus a square, right? So what do you do now? Take x minus 3 as t. So dx is equal to dt, right? So once you have dx is equal to dt, I value becomes I is equal to integral dt divided by t square plus 2 square. Now, which particular integral is this particular type? 1 by x square plus a square, right? Which is 1 by a tan inverse x by a, isn't it? So this is going to become, here only we'll finish this one. You get I is equal to 1 by a, so 1 by 2 tan inverse t by 2 plus c, correct? So 1 by 2 tan inverse, what is t? X minus 3. X minus 3 divided by 2 plus c. So finally, this is going to be the answer. 1 by 2 tan inverse x minus 3 by 2 plus c. Clear? So this is the answer for the first question. Now, let's do the second one. See the second one. Here you have integral of dx over root of 5x square minus 2x. Right, 5x square minus 2x. So here also what we need to do, we need to write this in the whole square form. Understood? So first and foremost, let's take this value. You have 5x square minus 2x. There is a minus sign. Since there is a minus sign, it has to be what? A minus b whole square. Right? So let's equate. This is a square minus 2ab plus b square. Correct? Compare. A value is going to be x value. But, okay, so a square is 5x square. A value is going to become root 5 into x. Correct? Next, minus 2ab is minus 2x. So the minus 2 cancels. Root 5x into b is equal to x. X and x cancels. So what do you get? B is equal to 1 by root 5. Correct? So b square becomes what? 1 by 5. Fine? So now, what do we have? You have 5x square minus 2x. This will be equal to root 5x whole square. That's a square minus 2 into a value is what? Root 5x into 1 by root 5. But what do? We add and subtract b square, correct? You add b square 1 by 5, you subtract b square 1 by 5. Fair enough? So plus 1 by 5 minus 1 by 5. Now group. Always group this much. That is a square minus 2ab plus b square. You should get it in that particular format. Till then you have to group. Fair enough? So once you group this, you will get root 5x minus 1 by root 5 whole square, correct? Minus 1 by 5. Fair enough? So this is what you're going to get in the denominator. So let's put it across the formula what we have. Formula in the sense the problem. All right. So integration I is equal to integral of dx over root of root 5x minus 1 by root 5 whole square minus 1 by root 5 whole square. This is of the form 1 by root of x square minus a square. If you all remember the formula, it is log of x plus root of x square minus a square plus c. Correct? We have to apply that. Whereas there is an issue, small issue. That is, it's not x square minus a square. Instead of x, you have root 5x minus 1 by root 5 something something. Right? So let's do the substitution method and let's do the problem. Alright? We substitute root 5x minus 1 by root 5 as t. Alright? So you get root 5 dx is equal to dt, or dx is equal to 1 by root 5 dt. So the integral I value will change. I is equal to 1 by root 5 integral of dt by root of t square minus 1 by root 5 whole square. Now this is in the form of that log function, correct? So now we directly apply the log function and get this problem done, right? What we get now, I is equal to 1 by root 5 into log of, so log of x plus root of x square minus a square. But in place of x, what do you have? You have t. So log of t plus root of t square minus 1 by root 5 whole square. So I'll just write it as 1 by 5. Okay. Plus c. So what is t? Root of 5x minus 1 by root 5. Substitute. So I is equal to 1 by root 5 to log of root 5x minus 1 by root 5 plus root of root 5x 1 by root 5 whole square minus 1 by 5 plus c. So this is going to be the answer for the second one. Okay. Now, in this one, remember the formula, remember how to do the whole square part. This is the whole point. Okay, let's do the third question now. In the third question, you have dx over 9x square plus 6x plus 5. Right? So, there is a plus sign in the sense, if you look at the denominator, 9x square plus 6x plus 5. So, we compare this with a square plus 2ab plus b square. Remember, plus 2ab plus b square. Okay. So when you compare this, what do we get? A is equal to 3x, because a square is 9x square. So a value becomes 3x. Next, 2ab is equal to 6x. So 2 into 3x into b is equal to 6x. So b value becomes 1, right? So much more easier. B becomes 1. That means the value whatever we have, see 9x square plus 6x plus 5. So we can write this as 3x whole square, that's a square, plus 2ab, 2 into 3x into, what is b value? 1. So plus 1 square minus 1 square plus 5. You might be thinking, where is this 5 coming from? This 5. You're not moving that 5 anywhere, isn't it? You just added 1, you subtracted 1. But that 5 remains as it is. 5 is not going anywhere. Okay, now what do? You group. This much you group. If you group them, 3x plus 1 whole square plus 4, right? So now what do? You're going to take I is equal to integral of dx over 3x plus 1 whole square plus 2 square. But then again you have to do substitution. That is, let 3x plus 1 is equal to t. So 3 dx is equal to dt, or dx is equal to 1 by 3 dt. Correct? Substitute. So you get I is equal to 1 by 3 integral of dt divided by t square plus 2 square. Which trigonometric function? 1 by x square plus a square. That is the, sorry, not trigonometric, integrating function. 1 by x square plus a square. That's 1 by a tan inverse x by a, right? So here you are going to get 1 by root 3 into 1 by a tan inverse t by 2 plus c, correct? What is t? 3x plus 1. So you get 1 by 6 tan inverse 3x plus 1 by 2 plus c. So this is the final answer for the third question. Fair enough? Let's do the fourth one now, the last one. In the fourth one, it's actually the easiest of all the three because it's given to you in the whole square form. You don't have to convert into whole square, right? So you have I is equal to integral of dx over 1 plus 2x whole square, right? 2x whole square is 4x square. See, this is already in the form of 1 by, see, it's already in the form of 1 by root of a square plus x square, or x square plus a square, which is what? Log of x plus root of x square plus a square plus c, correct? This is the formula. So if you apply that particular formula here, see what we'll get. You're going to get I is equal to log of, oh, there is one small issue which we have to address that particular part. That is substitution method. All right, we need to substitute 2x as t because we have 2x. There is a coefficient to the x, correct? So what do? You take 2x as t. So 2 dx is equal to dt, or dx is equal to half dt. Substitute, you get I is equal to half integral of dt by root of 1 plus t square, or half log of t plus root of 1 plus t square plus c. What is t? 2x. So you get I is equal to half log of 2x plus root of 1 plus 4x square plus c. So this is going to be the final answer for this fourth one. Okay. Now in the next video, there are few other types. That is, what if the numerator has something like px plus q, or what if the numerator has something where you have a linear equation, a linear polynomial. Then how do we solve those kind of problems? We'll discuss about these things in the next video.